Okay, we have this new section, section 5.3. This is the last section for chapter 5, the normal distribution. And this is the most important section, okay? So in 5.1 and in 5.2, we started talking about continuous random variable and its probability distribution, okay? For the continuous random variable, how do we represent our probability distribution if we have a continuous random variable? What do we use to represent the probability distribution for continuous random variable? We use a smooth curve, right? In section 5.2, we talk about the uniform distribution and finding the probability that x takes any number is same as finding the area under the curve, okay? So this is gonna be the same concept here in section 5.3 as well. Okay, now if we have a distribution, okay, if our probability distribution looks like a bell shaped, so we have this probability distribution and this probability distribution looks like a bell shape, then our distribution is normal distribution. Okay, you have a smooth curve and your smooth curve looks like a bell shape, then it is a normal distribution. And what do we know? What is the other name for the bell shape? It has to be, it's a mound shaped or symmetrical, okay? So it's the same thing. And this symmetrical has a mean and median exactly same. So the easiest way is that you look for the shape of a probability distribution, and if your probability distribution is a bell shaped, then we call it a normal distribution, okay? We have our x, this is our continuous random variable, x-axis, and our y-axis is f of x, okay? Now, as we did in section 5.2, we are interested in finding the function for this curve, okay, which we call density function, and our density function is given by this one here, okay. You don't need to, this is a lot to memorize, so you are not required to memorize, okay, but we use this formula to find the function of our normal distribution. Okay, let me write that one more. Okay, sorry. So here, so f of x is the function. F of x is the function. Okay, that's the function for this curve, equals to 1 over sigma. What is the sigma? That is the standard deviation for this probability distribution. Okay, times 2 pi, we all know what is pi, right? E to the power, so E is also a number, negative 1/2 time x minus mu. What is x minus mu? That is, mu is the mean, right? Divided by sigma and square, okay. So it's the same formula. So we use this formula to find the function, okay, to find the equation for this curve. So you will need the sigma, you will need mu, okay, and everything. So E is a number, pi is a number, okay. To find the probability density function for a normal distribution, you need the mu, you need the sigma, okay. So this gives us the equation for our bell-shaped curve. Now here, mu is the mean of a normal random variable x, okay, sigma is the standard deviation, pi is 3.1416, E is 2.71828. Now, if we have this bell-shaped or a normal distribution, how do we find the probability? Okay, so if your curve, smooth curve, is normal, is a bell shaped, then we use table, okay, we use the normal table, okay, table of normal probabilities to find the probability if our distribution is normal distribution. I think so we have some part of a table here, but I forgot to print the complete table. Okay, I will bring that in our next class. But whenever you have the probability distribution, finding probability is same as finding the area. But here we do not find the area. We will use our normal table to find the probability. Okay, so every time if you see normal distribution, you are using normal table to find the probability. Okay, but the concept is same. Now before we use the table, let's define one more. Let's define a standard normal distribution. Okay, now if our normal distribution has a mean equals to 0 and a standard deviation equals to 1, that normal distribution is the standard normal distribution. Okay, so our normal distribution has a mean mu, normal distribution has a standard deviation sigma, but here we are talking about a specific normal distribution whose mean is equals to 0 and standard deviation is equals to 1. So every normal distribution with a mean 0 and the standard deviation 1, we call it standard normal distribution, and the variable related to this standard normal distribution, we call it G. Okay, so in our previous we had X. So if, okay, see, we use X to represent normal random variable. Okay, X is for normal random variable. But if we have a standard normal random variable, then we use G. Okay, so standard normal distribution looks like this. It is a bell shaped. Okay, the curve is bell shaped. The variable for this standard normal distribution, we use G variable. Okay, we do not use X. This is a standard notation. Okay, you must be using G. So we have G. This G tells us that our random variable is standard normal. Okay, this is a normal distribution, and this normal distribution always has a mean. Mean is at the center, always has a mean equals to 0 and standard deviation is equals to 1. So every normal distribution with a mean equals to 0 and standard deviation equals to 1 is our standard normal distribution. Now, does it mean that every normal distribution has a mean equals to 0? Okay, normal distribution, it can have any mean, but this standard normal distribution is the specific one. Okay, once you have the standard normal distribution, you should know that its mean is always 0 and its standard deviation is always 1. Okay, it does not mention that mean is 0, standard deviation is 1, but from that name, from that standard normal distribution, you have to understand. Okay, you have to understand mean for that distribution is 0, standard deviation is 1. Okay, so make sure you know the standard normal distribution. And if we are finding the probability for a normal distribution, we have to convert that probability distribution, normal distribution, into standard distribution, and we use the table. Okay, now, so before we go to the normal table, do you have any question here? So just two things. If our smooth curve is bell shaped or a mound shaped, our distribution is normal distribution, right? And if our normal distribution has a mean equals to 0 and standard deviation equals to 1, we call that normal distribution as a standard normal distribution. Okay, and for that standard normal distribution, we use G to represent our variable. Okay, so G is for only standard normal distribution. So G is the variable that we use for standard normal distribution, and for normal distribution we can use X. Okay, so whenever you see G, yes.
Will we ever run into if the mean and standard 0 and the other one's number, or one's 1.
Can you repeat that?
So for example, if the mean was like 5, but then the standard deviation was 1.
Then that is not a standard normal distribution. It is a normal distribution, but not a standard. These two has its and, okay? Mu has to be 0 and sigma has to be 1. The both condition has to be satisfied to be a normal distribution, standard normal distribution, okay? So mu has to be 0 and standard deviation has to be 1. But if you have something then other these 0 and 1, they are simply normal distribution. They are not a standard normal distribution. Okay. Now the next here, as I said earlier, we will use normal table to find the probability for normal distribution. Okay, and we have this normal table. So let me just draw the same graph. So we have a standard normal distribution. So we have a standard normal distribution means what do we know? We know the variable is g. Okay. So we are talking about standard normal distribution. So the variable is g. The function related to this standard normal distribution is f of g, not x. Okay, we are using g. It means we are using standard normal distribution. We are taking a distribution whose mean is 0 and standard deviation is 1. So we have a g here, and we know its mean is always 0. Okay, and we also know sigma is equals to 1. We are talking about standard normal distribution. Okay, now so mean is at the center. So let me draw a vertical line at the center. So what do we know about the total area under this curve? What is the total area under this curve? It's always equals to 1, right? So here our area is same as probability. Okay, so we are talking about continuous random variable, and finding the probability of that continuous random variable is same as finding the area. Okay, so in a probability distribution, the sum of probability is equals to 1. Now here we have area. So the total area under the curve is 1. We know mu, we know this is a symmetrical, okay, this is a bell-shaped, mu is at the center. So what do we know about the area on the left of mu? What is the total area? What do you think here? 50%. It's a 50, which is 0.5, okay? In the similar way, the area, the total area on the right of mu, okay, it is also 0.5. And this is true when we have normal distribution. Okay, when we have bell-shaped or a symmetrical data set, this is true. Okay, now here our target is finding the probability. Now our normal table, it gives the probability. Okay, so we have this table here. We'll practice this, and our normal table gives the probability that g takes a number greater than 0 and less than, okay, let me call g naught. Okay, so g naught, let's say g naught is somewhere here. So here, so we have this normal table, and this normal table always gives the probability that g is greater than 0 and less than some g naught value. Okay, so our g naught is here, and finding this probability mean finding the area of this part. Okay, we have the curve starting at 0, we have the curve starting at 0 and ending at g naught. So we have curve, so this is the point 0 and this is g naught. We have this curve. Okay, the area under this curve is the probability, and this probability is given by our normal table. We do not need to calculate area here. We will use our normal table to find the probability. So here it always gives the area, it always gives the area such that G is greater than 0. Okay, so here let me, so one more time. So for example, we have a bell-shaped curve. Okay, so this is our standard normal distribution. Since this is the standard normal distribution, our mu is always 0, so this is always 0. Okay, so 0 is at the center. Now if we want to find the probability that G takes any number from 0 to somewhere here, okay, we write that as a probability that this G takes a number greater than 0 and less than this point. So let me call this as a X, or like G naught. Okay, this is, so we draw vertical line at G naught. So we want to find the area under the curve from here to here. So this is our curve and we want to find this area, and this area is given by our normal table. Okay, always keep in mind that the G has, it always gives the area on the right of 0. Okay, the table. Now let's use this table here. Now in this table, so we have G. Okay, so this is, so we have G value on the first column. Okay, so this is 0, 0.1, 0.2, 0.3, 0.4. Okay, 1.1, 1.4, 1.5. Okay, and we have the second digit for the G over here. Okay, and this is 0.01, 0.02. For example, so if we want to find, so for example, let's take this G is our 1.5. Okay, let's say 1.52. So let's say we want to find the area. Okay, so let's say we want to find the area from 0 to 1.52. Okay, that's what we want to find. So let me call this is 1.52. So our target is finding the area of this green region. Okay, or we are trying to find the probability that G takes a number greater than 0 and less than 1.52. Now how do we use this table? So we'll look for 1.52 in the G table. So let's go to the G table here. 1.5. So 1.5 is here. Okay, so 1.5 is here, and we want, so our 2 is the second digit, right? After, so 2 is the second digit here. Now where do we find the second digit 2? So we have this second digit 2 here. So the corresponding G probability is, so we have this row and this column. So the 0.4357 is the probability that G takes a number greater than 0 and less than 1.52. Okay, let's practice one more. So for example, let's find, so we have G here. So this is 0. Let's say this is 0.57. Now let's find the area from 0 to 0.57. So let's find the area, and that area is same as probability. So we write that area as a probability that G takes a number greater than 0 and less than 0.57. So this is our green region. Okay, so G is greater than 0 and less than 0.57. Now go back to the table. 0.57. Now where do we find 0.57? So we start, so which row do we start? So 0.5. So this is 0.5. Now we want 7, right? So we have 7 here. So what do we have? So here So this is 0.2157. 0.2157 is the probability. Okay, so we always use the normal table to find the probability or to find the area. Okay, now okay, let's practice this here. Okay, or do you, before that, do you have any question? So okay, let me start from Imli. Okay, can you tell me? Okay, so let me draw. So we have this table. So let me draw a picture here just in case. So we have 0 here, and let me take 1.15. Now can you tell me what is the area from 0 to 1.15? This is G. So I want you to watch this, look at this table, normal table, okay, and give me the area from 0 to 1.15. Okay, 0.49. Okay, now let's see. So we have 1.15. So we look at the row with 1.1. So we have 1.1 here, and we need a 5, right? So we look for the column with 0.05. So here 0.3749. 0.3749. Now how do we write this area in terms of probability? So how do we write this area in terms of what is this area for us in terms of probability? That is the probability that G is greater than 0 and less than 1.15. Okay, all right, good. Okay, Faith. So we have the standard normal distribution, okay, and our G is 1. Okay, yeah, let's take 1.0. Now can you tell me the area of this region using the normal table? Okay, you said 0.3413. Okay, let's check that. Okay, so what row we are looking at? So our G is 1.0, right? So we look at the row with 1.0. Okay, now what is the next digit after 1.0? Is, I mean, if it's nothing, we can add 0, right? So it's simply 0. So we have 0.00 is here. So 0.3413. So this is the area for this green region. And how do we write in terms of probability? Faith, you have the second following question. How do we write this area in terms of probability? This is the probability that G is greater than 0 and less than 1. That's good. And this is 0.3413. Okay, Mariana. So for you, so 1.48. So what is this area for this green region? And your G is 1.48. You said 0.4306. Okay, now let's check. So you start with a row 1.4. So 1.4 is here, and we want 8. So 8 is here. So 1.48. So 0.4306. And how do we write this in terms of probability? This is probability that G is greater than 0 and less than 1.48. And this probability is equals to 4306. Okay. All right. And Andres, right? How do you pronounce? Is that how you pronounce your name, Andres? Okay. So for you, so let's. Does anyone have any question up to here? Okay. Okay, if our G is 1 point, okay, let me take 0.18. So if our G is 0.18, what will be the area of this green region? What will be the area of this green region? Our G is 0.18. So I want you to use this table and give me the area. It says 0.0714. Okay, let's check that. So you are starting with 0.1. So we have 0.1 here, and we want 8. So 8th column. So yeah, so 0.0714. And how do we write this in terms of probability? This is probability that G. So you start from G. G is greater than 0 and less than 0.18. Okay, Jonah. So, okay, what would be the probability if G is 1.25? Do you need a picture? 1.25. So you are looking at 1.25, and what will be the probability? Yes, so 1.2 is here, 5 is here. So 0.3944. And what is this 0.3944 for us? Five. Okay, good. Okay, Sam, right? Okay, so what is, okay, now let me ask you in different way. So what is the probability that G takes a value greater than 0 and less than 0.87? Let me write down that for you. So what is the probability? What is the probability that G takes a number greater than 0 and less than 0.87 using a table?
0.3078.
0.3078. Let's check that. So 0.8. So you start from 0.8. So it's here, and 7. So 7 is here. Okay, yes, 0.3078. Okay. Jaden. So what is the probability that G takes a value greater than 0 and less than 0.39? What is the probability that G takes a value greater than 0 and less than 0.39? 1517. Okay, let's check. So you start from 0.3. So we have 0.3 here and 9. So 9 is here. 0.1517. Okay, good. Okay, Brian. So what is the probability that our G is greater than 0 and less than 1.30?
0.4032.
Okay, 0.43?
No, 4032.
4032. Okay, so we start from 1.3. So 1.3 is here, and 0 is the first column. So 0.4032. Okay, good. Alexandra, so what is the probability that G takes a number greater than 0 and less than 0.64?
0.2389.
0.3289.
2389.
Okay, 2 3, thank you. 2 3 8 9. 2 3 8 9. Okay, let's check that. So we start from 0.6. So 0.6 is here and 4 is here. Let me get rid of this first. So 4 is here. Okay, 0.2389. Okay, that's good. Okay, Denara, right? Okay, can you tell me the probability when G is greater than 0 and less than 1.38? Point 4162. Okay, let's check that. 1.3 is here, 8 is here, so 4.1. yes. Okay, so our G table, okay, so this gonna be, so you will be given with a table. Okay, there is not a lot of calculation here. So once we have the normal distribution, we use the G table to find the probability. Okay, now let's, okay, so for number 1 we need a complete table. Okay, I think we can do it. Let's see if we can do it, this one. Okay, so in number 1, the very first example, so what we are asked here is that, so we are asked to find the probability, okay, that the standard normal random variable, see, it does mention it, standard normal random variable G falls between negative 1.33 and positive 1.33. So every time if you are asked to find the probability, the very first step is you draw a bell-shaped curve. Okay, that's how we start. So let's start by drawing a bell-shaped curve. So that should be the very first step. Okay, so if you are asked to find the probability distribution for continuous random variable, then the first step is you draw a curve. Now since we are talking about a standard normal random variable, our curve has to be a bell shaped. And what is this, our horizontal axis? This is G, right? We are talking about a standard normal random variable. What do we know about the standard normal variable? What is its mean equals to? It's always 0. So let's write down mean. So this is our mean, 0. Now we are asked to find the probability that G falls between negative 1.33 and positive 1.33. Now where do we find negative 1.33 in our, here from 0? Is it on the left of 0 or right of 0? It's a negative number, right? So let's say negative 1.3 is here. What about positive 1.33? It's on the right, right? So this is positive 1.33. So we want to find that our G falls between negative 1.33 and positive 1.33. Okay, so let's talk about the graph. So our graph is starting at negative 1.3. So this is the point here, starting point, and ending point is here. So we want to find the area under this curve. So let's draw vertical line at negative 1.33 and positive 1.33 and vertical line at 0. Okay. Does any one of you have any question up to here? Now, it does tell us standard normal random variable. So we draw a bell-shaped curve. We know the mean is 0. Okay. And you look at these numbers. Okay. So negative 1.33 is on the left of 0 and positive 1.33 is on the right of 0. Now let me call this is area A1 and this is area A2. What can we say about area A1 and area A2? How they are related here? What do you think? Our graph is symmetrical. So what about A1 and A2? They has to be equals to each other, right? Because so this distance, so we have a same number 1.33 and we have 1.33. Okay, so we have these two area A1 and A2, they are exactly same. They must have exactly same area because our curve is symmetrical. Okay, now using our G table, okay, what our G table gives us? G table always gives the, okay, so G table always gives the probability that G takes a number greater than 0 and less than some G value. Okay, now using G table, let's find the area of the right side of 0. Okay, now what is the area A2? Okay, Faith, what do you think here? What would be the area A2? Our G is 1.33. So our A2 is same as finding probability that G is greater than 0 and less than 1.3. And what is this area equals to?
0.4082.
Okay, let's check that. So you start with 1.3. So 1.3 is here and 3. So 3 is, so this is 3. So 0.4082, right? So 0.4082. Any question here? So we know A2. What about A1? What is A1 equals to?
The exact
Same, right? 4082. So what is the total area now? Right. So the question that was asked is finding the probability. So we were asked to find probability that G is in between negative 1.33, in between negative 1.33 and positive 1.33, and this is A1 plus A2, which is 0.4082 plus 0.4082. And what is the sum, Jayden? Is 0.64. Okay. Any question up to here? I think part 2, number 2 is we already know what is. So it asks us finding G equals to 1.33 in the standard normal table, right? So we already know that is 0.4082. Okay, let's do number 3. Now I want you to draw, for number 3, I want you to draw the bell-shaped curve. Okay, at first I want you to draw the bell-shaped curve and set the area that we are interested here for part 3. So you start, so every time, okay, do not forget, if you are asked to find the probability for any continuous random variable, you start by drawing a curve. So here we have a standard normal random variable, and what is the shape of a curve we have to draw? Bell-shaped. So let's draw bell-shaped curve. So this is our G. What do we know about the mean of this distribution? It's 0. Can you write this statement in a notation, in a like a mathematical statement? So we are asked to find the probability. So we are asked to find the probability that a standard normal random variable. What do we use to represent a standard normal random variable? G, right? So we are asked to find the probability that G lies to the left of 0.67. How do we write that? Left to the left of 0.67. G has to be on the left of 0.67. Is it G greater than 0.67 or G less than 0.67? It is less than, right? So we want to find probability that G is less than 0.67. So this is the question here. And on the graph, so where do we find 0.67? Is it on the right of 0 or left of 0? 0.67 is positive, right? So let's take this here, 0.67. Okay. Now, can you say the reason we are interested in here? So we are asked to find that our G is less than 0.67, or we are interested in finding the probability that G lies to the left of 0.67. So what is the part on the left of 0.67? Everything on the left of 0.67, right? Everything. So we have all this region. So we are interested in finding the area of this region. Left of 0.67. Okay. Does anyone have any question up to here? Now, okay. So let me. Okay. Now, what do we know about? Only the green area of green now. So what do we know about the area of green? Isn't that 0.5? Do you all agree that's 0.5? Because our 0 is here, okay? So this is the 0 here. Okay, this is the 0 here. And the area, total area on the left of 0 is always 0.5. The total area on the right of 0 is always 0.5. So we already know this is 0.5. Okay, now we need to find the area of this part. Okay, and how do we write the area of this part? What is this? This is the probability that our G is from 0 to 6 point. G is greater than 0 and less than 0.67. And where do we get this area from? From normal table. Now we look at our normal table and find the area or find the probability that G is greater than 0 and less than 0.67. Okay, Alexandra, what do we have this area? Can you help me here? So you are looking at 0.67.
The answer is 0.2486.
0.2486. Okay, let me check it. 0.67. So 0.6 is here and 7 is here. So 0.2486. Okay, 0.2486. Now, can you tell me what will be the area on the left of 0.67? That is 0.5 plus this area, right? 0.2486. And this is 7486? Okay. Does anyone have any question here? Now, in the same question, if you were asked to find the probability that our G lies to the right of 0.67, what will be the probability? Like right of 0.67 means if you are asked to find this area. We already know the area on the left of 0.67, which is 0.7486, right? So the remaining from 1, the 1 minus 0.7486 would be the area of this region. Okay, I know this is very, yes, you have a question? Okay, I know this is very new for you, okay, and we will practice a lot, okay, and this is the most important, you all need to know. And once you understand the concept here, there is not much calculation here. You draw the smooth curve, you look at the table, you get the final answer. Okay, so let's do this much for today. And if you have any question, I will be here for a while. If not, I will see you, yeah, it's after a week, right?